What is a blockchain? A blockchain is a distributed database or ledger shared among a network of computers, known as nodes. Its most renowned application is in cryptocurrency systems, where it plays a vital role in maintaining a secure and decentralized record of transactions. Security is ensured since the majority will not accept this change if somebody tries to edit or delete an entry in one copy of the ledger. Because blocks in a blockchain are tamper-proof, trust is primarily required at the point where data is entered by a user or program. This unique feature reduces the reliance on trusted third parties, such as auditors or intermediaries, which often add costs and introduce the potential for errors. Since the introduction of Bitcoin in 2009, the use cases for blockchain have expanded significantly, giving rise to various cryptocurrencies, decentralized finance, DeFi, applications, non-fungible tokens, NFTs, and smart contracts. How does a blockchain work? While you may be familiar with spreadsheets or databases, a blockchain, in some ways, functions similarly as it stores and manages data. However, the key distinction lies in how data is structured and accessed. A blockchain comprises programs, known as scripts, which carry out tasks analogous to those in a traditional database, inputting and accessing information and storing it. Importantly, a blockchain is distributed, meaning multiple copies of it are stored on numerous machines, and all copies must match for it to be valid. A blockchain collects transaction information and records it in a block, similar to a cell in a spreadsheet containing data. Once a block is full, the information undergoes encryption using an algorithm, resulting in a hexadecimal number known as a hash. This hash is then included in the subsequent block's header, where it is encrypted along with other block data. This process creates a chain of blocks, all interconnected. Transaction process. The process of transactions varies depending on the blockchain in use. For example, in the case of Bitcoin's blockchain, when you initiate a transaction using your cryptocurrency wallet, a software interface for the blockchain, a series of events unfolds. In Bitcoin, your transaction is first sent to a memory pool, where it is queued until a miner or validator selects it. Once included in a block and the block fills with transactions, it is sealed and encrypted using an encryption algorithm. Subsequently, mining commences. The entire network simultaneously competes to solve the hash. Each miner generates a random hash, except for the nonce, an abbreviation for number used once. Every miner begins with a nonce of 0, which is added to their randomly generated hash. If this number exceeds or doesn't meet the target hash, a value of 1 is added to the nonce, generating a new block hash. This process continues until a miner discovers a valid hash, winning the competition and receiving a reward. However, it is not confirmed until 5 subsequent blocks have been validated, a process taking approximately an hour, given that each block averages just under 10 minutes. Not all blockchains adhere to this process. For instance, the Ethereum network employs a different mechanism, randomly selecting one validator from all users with staked Ether to validate blocks, which are then confirmed by the network. This approach is faster and less energy-intensive compared to Bitcoin's process. Blockchain decentralization. A fundamental feature of a blockchain is its ability to distribute data across multiple network nodes, computers or devices running blockchain software, located in various places. This not only ensures redundancy but also maintains the integrity of the data. For instance, any attempt to alter a record in one instance of the database would be thwarted by the other nodes. This way, no single node in the network can manipulate the information it contains. A blockchain can store various types of information, such as lists of transactions, legal contracts, state identifications, or a company's inventory. Blockchain transparency. Owing to the decentralized nature of the Bitcoin blockchain, all transactions are transparent and can be viewed by anyone with access to a personal node or by using blockchain explorers, which allow real-time monitoring of transactions. Each node maintains its copy of the blockchain, updating it as new blocks are confirmed. Consequently, it is possible to track the path of a Bitcoin through the network. For instance, cryptocurrency exchanges have been targeted by hackers in the past, leading to substantial losses. While hackers may remain anonymous, their cryptocurrency transactions are traceable because wallet addresses are publicly recorded on the blockchain. However, it's important to note that the records stored in the Bitcoin blockchain, like most others, are encrypted, ensuring that only the individual assigned to an address can reveal their identity. As a result, blockchain users can maintain anonymity while upholding transparency. Is blockchain secure? Blockchain technology ensures security and trust through decentralization. To begin with, new blocks are always added linearly and chronologically to the blockchain, meaning that once a block is appended, previous blocks cannot be altered. Any alteration to data within a block would change the block's hash. Since each block contains the previous block's hash, any change would cascade through subsequent blocks, causing the network to reject the altered block. For example, consider a scenario where a hacker attempts to tamper with a blockchain and steal cryptocurrency. If they modify their copy, they would need to convince other nodes that their version is the valid one. Achieving this would require controlling a majority of the network, known as a 51% attack, as more than 50% control is needed. Moreover, timing is crucial in such an attack, as the network continuously advances, making it challenging to alter past blocks. The speed of these networks' hashing capabilities is exceptionally high. For instance, the Bitcoin network reached a hashing rate of 348.1 exahashes per second on April 21, 2023. Bitcoin versus blockchain. Blockchain technology was initially proposed in 1991 by Stuart Haber and W. Scott Stonetter to secure document timestamps. However, its first practical application emerged with the launch of Bitcoin in January 2009. Bitcoin's protocol is built upon a blockchain, described by its pseudonymous creator, Satoshi Nakamoto, as a new electronic cash system that's fully peer-to-peer, with no trusted third party. It's essential to distinguish between Bitcoin and blockchain. While Bitcoin utilizes blockchain to transparently record transactions, blockchain can be employed to immutably record various types of data, such as votes in elections, product inventories, property records, and more. Blockchain versus banks. The introduction of blockchain technology has disrupted various sectors, particularly in the realm of banking and finance. Traditional banks typically operate during business hours, while blockchain operates 24/7, 365 days a year. This results in faster transaction processing times, regardless of holidays or time constraints. Blockchain integration into the banking sector could significantly expedite transaction verification and settlement, reducing costs and risks associated with delays. Stock market settlement processes, for example, can take several days, whereas blockchain could drastically reduce this time frame. Additionally, blockchain offers the potential to provide banking services to the unbanked population in developing countries, offering a secure means of storing wealth and conducting financial transactions. Currency. Blockchain forms the foundation for cryptocurrencies like Bitcoin. Unlike traditional currencies controlled by central authorities, cryptocurrencies operating on blockchain networks provide individuals with more control over their financial assets. The public nature of blockchain ensures transparency and accountability in cryptocurrency transactions. Bitcoin, being the first and most well-known cryptocurrency, has gained significant attention as both a digital currency and an investment asset. Its limited supply of 21 million coins, the decentralized nature of the network, and its deflationary properties have contributed to its popularity. The blockchain's ability to facilitate peer-to-peer transactions without intermediaries has also fostered the growth of decentralized finance, DeFi, applications. DeFi platforms leverage blockchain technology to offer various financial services, such as lending, borrowing, trading, and earning interest on crypto assets, without the need for traditional banks or financial institutions. Smart contracts. Blockchain technology has introduced the concept of smart contracts, self-executing agreements with the terms of the contract directly written into code. These contracts automatically execute when predefined conditions are met, eliminating the need for intermediaries and reducing the risk of contract disputes. Smart contracts find applications in various industries, including supply chain management, real estate, insurance, and more. For example, in supply chain management, blockchain-based smart contracts can automate the tracking of goods, verify their authenticity, and trigger payments when delivery is confirmed. Blockchain challenges and future outlook. While blockchain technology offers numerous advantages, it also faces challenges, such as scalability issues, energy consumption concerns, particularly in proof-of-work blockchains like Bitcoin, and regulatory scrutiny. Addressing these challenges is crucial for the widespread adoption of blockchain in various industries. Number of blockchains. As of 2023, there are over 23,000 active cryptocurrencies based on blockchain, along with several hundred non-cryptocurrency blockchains. Public versus private blockchains. Public blockchains are open to anyone, using robust security measures like proof of work. Private blockchains require node approval, as nodes are considered trusted, reducing the need for robust security. In conclusion, blockchain technology has revolutionized the way data and transactions are managed and secured. Its decentralized and transparent nature, combined with its cryptographic principles, has opened up new possibilities across industries, from finance and supply chain management to voting systems and beyond. While blockchain is best known for its association with cryptocurrencies like Bitcoin, its broader utility is driving innovation and reshaping traditional processes across the world.